The ordinary limit. Let L be an element of R. Follow my cursor. Let A be less than B, and let C be an element of the closed interval AB. Let the reals be a superset of D, and let D be a superset of the deleted closed interval AB with C taken out. Whether D contains the element C, we don't know. It might not. Let F be a function from D to R. We say that the limit as x goes to C, where my cursor is, of f of x equals L, sorry about the space down there, if f of x gets arbitrarily close to L as x gets arbitrarily close to C. We do not promise that f of C necessarily equals L, or even that it necessarily exists at all. In the event that f of C equals L, we say that f is continuous at x equals C, and we have the limit x goes to C of f of x equals f of C. That's if we get lucky, though. A function that is continuous at every point in its domain D is said to be continuous on D. That's just a definition. If a function is not continuous at a point, it is said to be discontinuous at that point, naturally. In this class, the continuity of the following functions in their appropriate domains will be taken for granted. Namely, polynomials, rational expressions, absolute values, trigonometric functions, inverse trig functions, exponential functions, logarithmic functions or logs, and roots. Here's some examples of the limit. The limit as x gets arbitrarily close to 0 of x over x, that equals 1. Even though x over x is undefined and hence discontinuous at x equals 0. So we can get indefinitely close to 0. In particular, x can get arbitrarily close to 0, but it can't hit 0. It can't equal 0 itself. However, on the other hand, down here where my cursor is, the limit as x goes to 5 of x over x, now that really does equal 5 over 5, and x can really hit 5, in which case f of x will give us 5 over 5, which is 1. I'm letting f of x, of course, is understood to be x over x. So we get 1 where x over x is continuous at x equals 5. We're lucky to have continuity at 5. In fact, x over x is continuous everywhere except x equals 0. That'll be all for this video. Let's move on to the next video.